Hello and welcome back to another episode of How to Program in Android Studio. We don't have a specific name for this series. Anyway, so today what we're going to talk about is how to program your OP mode, which is also known as the code that is on the robot during the driver-controlled phase of any FTC game. Today we're going to simply talk about how a tank drive works. In future episodes we'll also cover how mechanism wheels work and how to program an autonomous. So today we're going to be looking at a basic tank drive setup that we've used to base off our code in seasons past. So let's just start from the top. So at the very top we have these things called imports. And what these imports do is that we're taking from a certain database specific variables and other things of that sort. Now, for those of you at home who are really interested in code and specifically how this import code works, I don't even know to the fullest extent either. And even if I wanted to explain it, it'd be extremely boring and not that relevant. All you really need to know is that each of these import codes allows us to bring in variables that aren't preloaded into Android Studio, as Android Studio is normally used for making apps and not robot code. And it also allows us to access variables for our various devices that we're attaching onto our robots, such as DC motors, servos, and an elapsed time function if you really need it. We move on to this TeleOp command that essentially states what the code is. We've named ours Lucifer in honor of our coach, Mr. Luce, and it's a funny pun. However, in reality, you might want to name your code something more productive, like code 1, code 2, this code works well, this code doesn't work well, or something that's more direct, because you don't want to confuse your driver team who, when they need to pick up a certain code, when they need to choose a certain OP mode, they don't want to look at a bunch of stupid names that only you understand. Over here beyond that is a hardware map. What this does is it declares what our OP mode members are. So it tells us that we are using a left motor and a right motor. We're using a back left motor and a back right motor. We're using a pulley motor, which we just call it a pulley motor because I'm too lazy to change it. It's that motor specifically for our purposes will be any sort of auxiliary motor that you use for a grabber or a pulley. And we also have two servos. One of them is being commented. So what this does, it tells our robot exactly what motors and what servos and what other devices are going to be used. And if we attach a motor that we have not declared in the code, or we remove a motor and it's looking for a motor to control, the robot is 9 out of 10 times going to shut down and not do anything simply because the OP mode does not work with what the robot has been designed to do. So when you are programming, make sure that everything in this hardware map is what you need and as you need it. After that, we start off with the actual meat and bones of the whole program, which is the code that runs once the driver hits initialize. This override sequence first assigns each variable that we've declared to a specific part in the hardware map. Now, what's important to understand about this hardware map is that because the robot, at least with the modern robotics wiring system, I'm not sure if this applies or pertains to the Rev system, it specifically assigns motors to random locations. So whatever you wire up your robot to, you have to go into your phones and hit the configure motors to make sure that each motor is in the right spot. So whatever you name it, that's not automatically where it's going to go, because the phone doesn't know that. Other than that, we've declared everything. So these strings that you see in my argument over here, these are what they will be known as in the phone. The purple text, as you see, is how it will show up in your code. So either make sure both are named the exact same way, or be sure to differentiate. And always check if your name is in the config file. Otherwise, again, your robot will not work. Moving on, this is the actual movement. So, as I stated earlier, this program is a tank mode drive. And what a tank mode drive does is that we're taking one joystick to control the right wheels and one joystick to control the left wheels, so that we can turn using like inverting the two joysticks. We can go forward, pushing both joysticks forward, backward, pushing both joysticks backward, and not side to side, because we don't have mechanism wheels on, which we will come to in a later date. Other than that, we have these other statements that talk about the direction of the motor, simply because the way the motor rotates, maybe that's not exactly the way you want it to, and so such and so forth. Now, to break down the real nitty-gritty of the program, if you're very interested, this telemetry add data statement right here essentially tells us how long the robot's been running for, and it's also sort of a debug statement to just have a checkpoint in place to let us know that the robot is still running. These left motor set powers, I'm multiplying them by a scalar of 0.85, because sometimes when we set our motors to max speed, bad things can happen if our parts are a little broken, which this season they were very heavily used, so we had to take down the speed to make sure that absolutely nothing falls off. The pulley motor right here will depend on how you set up your robot. Maybe you want it to rotate one way, maybe you want it to rotate another way. An important note to keep in mind when you are running your wheels is that when the joystick goes forward, the output that comes out is negative. Now, the joystick is only going to output 1, -1, and numbers in between. So when it goes forward, that's -1, and when it goes backwards, that's +1 in the y direction. Now, what makes this complicated is when you're trying to figure out if the motor's output should be negative and what your joystick is outputting. So either you can lab this all out yourself, or if you're really good at it, you can just figure it out on the fly and just play around with negative signs till it works. Moving on beyond that, we have a basic servo statement here, where we have, if the second gamepad presses the X button, one of our servos will be set to the 0 position, and if it opens, and if we want it to open, we'll press B to set it to the 1 position. And these telemetry points right here also display text on both phones to let us know if something is going wrong. Yeah, so this is just a basic application of servos. Obviously, if you want to figure out the specific position you need to set it to, you'll need to play around with that. But it's a basic application of a servo. For the most part, it's a very basic tank setup, as I've already discussed. There's nothing too special about it. As long as you can get the fundamentals down, this is basically your code for any sort of pushbot. What makes coding hard in the realm of FTC is the more and more attachments you put on, the more and more complex and convoluted your code can get. So it's important to keep track of everything you're doing. That's why it's important to comment your code, so that if you have multiple programmers on your team, or you just have yourself and you have not the greatest memory, it's important to comment your code so that you know exactly what part of the code is doing what. Otherwise, you'll run into scenarios where you programmed something last week's meeting, and then you come back for this week's meeting and you don't understand what left motor set power means or what right motor set powers means. Comments can also be applied so that you can create a to-do list such as this. So, to-do, make programming video. And the joke is that I don't make a lot of those because YouTube is hard. Other than that, the code's very straightforward. In terms of this bottom thing you see here, we don't need to talk about that. Other than that, I think that'll be it for this episode. I'll probably throw in some sort of video of the robot just using this basic code in practice. Sooner or later, we'll talk about mechanism wheels and autonomous, but as of right now, we still don't really have a good out